All right, so today's date is the 10th. So we're going to review some vocabulary from Math 3, and then we're going to learn something about graphs and zeros and extrema, which is new. So the big thing is you guys will identify some key characteristics of polynomial functions. So the first thing we're going to talk about is what is a polynomial again? So the prefix poly means many or much. A non-constant polynomial is a function with many terms in the following form. So the fancy way to write this looks like this. A sub n, x to the n, plus a sub n minus 1, x to the n minus 1, plus a sub n minus 2, x to the n minus 2, plus dot dot dot, plus a sub 2, x squared, plus a sub 1, x, plus a sub 0. And I'll explain to you guys what that means. So, bless you. Do you guys remember in Math 3 that we talked about like writing a polynomial in standard form? Where it's like the highest power all the way to the lowest power? Do you guys remember that? Okay. So if you guys look at the x's, do you guys see how it's x to the n, and then x to the n minus 1, and then x to the n minus 2? That just means that whatever, it starts at n, and then it just gets smaller. That's what it means. All the way down to like the squared term, the x term, and then this is what we call the constant term, the term that's on the very end. All these are just the coefficients. So these are just numbers. Okay, that's all that means. It's just different numbers. So n is a positive integer, and then anything that's an a is a real number that's in front of the x's. Okay, it's just a really technical way to write this. So if we look at this example, if you guys could write this down. 7x to the 5th minus 3x squared plus 6x minus 2. So my question to you guys is this in standard form? It is. Because notice that the degrees go from largest to smallest, right? So the leading term, guys, if I ask you guys, hey, what's the leading term? What's the very first thing I wrote down? Not to 7, the whole thing. 7x to the 5th, okay? This polynomial has degree what? 5. And then the leading coefficient is 7. Okay, so 7 and, oh no, just kidding. 5 and 7. It is possible that they'll ask you guys this as a multiple choice question on the AP test too, so please don't miss this on the AP test. Okay, what's different about B? It's not in standard form. So the first thing I highly recommend you guys do is rewrite it in standard form first. So which term would go first? Good, so negative 2x to the 6th. What comes next? So plus 14x squared plus 6x plus 1. So what's the degree? 6. What's the leading coefficient? Negative 2. Cool. Well, that was easy. Questions on those? All right, so let's talk about something that's new. See that? It like flew into my glasses. Go away. Okay. Now, you guys have already learned a little bit about this in Math 2 and Math 3. But in Math 2, you guys learned about parabolas. Parabolas have a vertex, right? The vertex, remember, is always the highest or lowest point on the graph. Does that sound familiar? Okay, so even though this doesn't look like a parabola, it kind of looks like a parabola, right? Do you guys agree that it has like a highest point right there? So the definition of, would this be a maximum or a minimum then, based on what you guys have learned? A maximum, right? So what you guys have learned is a maximum is like the highest point. But the technical definition is, do you guys remember from the first section of this class, we talked about increasing, decreasing? So you read a graph from left to right. If I'm right here and I'm following the graph, is this going up or down? So you guys agree that's increasing, right? And then all of a sudden it stops and then it starts to decrease, right? So if it switches from increasing to decreasing, we say that it's either called a local, or sometimes you guys will see the word relative maximum. So increasing to decreasing, it's called a local or relative maximum. On the flip side, if it goes from decreasing, so something like this, decreasing to increasing, that point right there would be a minimum. Okay, so if a polynomial switches from decreasing to increasing, we call it either a local or relative minimum. Okay, so I know there's not a lot of space, but in this little space, before we do this part, I'm going to draw like a little graph right here. So something like this. Let's pretend like our graph looks like this. So we read a graph from left to right. Right. Okay. So then if I'm starting here and I want to start traveling, which direction do I have to move, up or down? Up. So right here, do you guys agree this is increasing, right? And then it switches to decreasing. So right here, this is what we'd call, listen guys, this is what we call an extrema. If it's a max or a min, it's called an extreme value or an extrema. Okay? Then it starts to go down. And then it switches and starts to go up. So this is also an extrema. Does that make sense? Okay. If you guys are looking at me like, why is he going so slow on this? Every year I teach this, kids are super confused. And so I really want to make sure you guys understand this. Okay? So if you're local, like local to Porterville, for example, does not mean like close to us. Does that make sense? So on the graph, when we say a local minimum or local maximum, this is an extreme value, right? So this is either a local min or local max. So what we're talking about is like really like in between these 2 points. Is that a maximum or minimum point? I'm asking you guys. Is that a maximum or minimum? Maximum. So this would be, label it, this is a local max. which makes this a local min. Now, this part is also kind of confusing, and even for myself, I have to really think about these. Sometimes you guys will be given a graph where it's just like a piece, okay? So if you have endpoints, the included endpoints of a polynomial may also have a local or relative extrema. So this right here, if I'm talking about locally, I'm talking about like really close to that endpoint. So do you guys see like what I'm using my laser for? Would that be the lowest or highest point of this area? The lowest, right? It's the smallest, so this would be a local then what? Minimum. So this right here would represent a local minimum. And then same thing down here, if I'm looking at just this part of the graph, that endpoint is at a max or a min. It's also a minimum. So this is also a local minimum. That looks terrible. Now, is there a local maximum on this graph? Yes? I see some yeses and I see some nos. Remember, a maximum means it goes from increasing to decreasing. Does this graph do that? Yes. Where? At y is 3, but what's the x value? 0. So at the point x equals 0, this would be a local max. Okay? That tricked you guys, right? Because there wasn't a point there, so careful. Now, locally means just within a small area of the graph, right? But there's also what we call a global or absolute maximum or minimum. These ones are easier to understand. So whenever I tell you guys something is the absolute max, that's the more common way to say it. But in AP calculus, sometimes they'll call it global max. I don't like that phrase, but you guys will see that sometimes. But they mean the same thing. If you guys look at this graph, we labeled this point right here as a local max, correct? Is there a highest point on this curve other than that point? So this is the local max then, but it's also the absolute max because it's the highest point. We have two local mins right here, right? Which one is the lower one? The one at x equals -1 or the one at x equals 2? X equals 2. So this would be the absolute minimum. That's what that means. The absolute maximum of all the maxima, the greatest is called the absolute max. And then of all the local minima, the least is called the absolute minimum. Okay, do we have questions on that? No? Okay. Then let's look at the next problem. Find the extrema and where they occur. If there are none, cross it off and write none. Okay, so the absolute min of this graph. Is there an absolute lowest y value on this graph? Not a trick question. Yes, thank you. Now, the way you're going to answer it is, what is the y value? -2? So it's at -2, and it occurs when x is equal to, what's the x value there? -6. Okay, so this next one's tricky. Is there an absolute max? So is there an absolute highest value? So this is the lowest value, right? If I'm following the graph, it looks like it's going down, then goes up, then goes down, then goes up, but does it ever stop? No. So do we actually know where it actually stops? Is there an absolute max? We could technically say infinity, but we're not going to do that. So this doesn't happen. So I'm just going to say none. Okay, relative mins. So to do the relative mins, it might actually be helpful to know where it's increasing, decreasing. So if I look at where I start here and I follow the graph, is it going up or down from this point? Up. So it looks like it's increasing and then stops, right? Then it starts to decrease and then it's increasing and then it decreases, boop, and then it increases. Do you guys see that? So if you guys can identify that from the beginning before you do the next part, it makes your life easier. Because wherever it switches, in my case from green to red, I'm gonna draw a little point. So there, there, and there. Because those represent either maximums or minimums. You guys follow me? Does that make sense? You good? You don't look excited about this. Okay, we'll talk later. All right, relative mins. So remember, an absolute min can also be a relative min. So do you guys see how this is the absolute min? We call that the absolute min. Don't forget to include that in your relative mins because it's also a relative min. Because in this region, isn't it the lowest point? You guys see what I'm saying? So we're gonna say x equals, that's at -6. Where else is a minimum where it switches from decreasing to increasing? -3. Anywhere else? 2. Good. Where are my maxes? -4 and 1. Cool. Is everyone cool with this? Does this make sense? Does the highlighting help? Okay. You don't have to highlight on your homework if you guys want to. Live your best life. You guys can if you want to. That might help, actually. I don't recommend maybe doing that on a test because then if you make a mistake, I guess I could give you guys another test. Like, here's another copy. But I don't recommend doing it on a test in case you messed up. Questions? Okay. Next idea. Okay, so this is a cool one. If you have two zeros of a polynomial and it's a non-constant polynomial. What does constant mean? A graph? You guys remember? Yes. Doesn't change, right? So what does that look like slope-wise? Straight, yes, but what does a constant function look like? Huh? A line, linear, right? But it's a special type of linear function. What does the slope of 0 look like? Can you show me with your arm? Like this, right? So what's saying is the function is a polynomial, but it's non-constant, meaning it doesn't look like this. Okay? Which means that if it's a polynomial, it could either do this, or it could do this. So if it has 2 zeros, okay, there has to be at least one local extremum between the 2 zeros. Why is that true? Remember, a 0 is when the graph crosses the x-axis, correct? So don't draw anything yet, just watch me. If this is a graph I have, so say it goes something like this, and it crosses the x-axis. If this is also a 0, does it make sense that this can't just go up forever? It has to come back down and cross there. It could just do something simple like this. It could do this. You know what I mean? Like, it doesn't have to necessarily be super simple like this, but it has to cross. So it has to come up and come back down like that. And the reason why that's important is because right here, do you guys see how it's increasing? And it stops and then starts to decrease. So what would this point represent? A maximum. Does that make sense? That's what this is saying. Between 2 zeros, there has to be at least a maximum or a minimum, because otherwise I could have also drawn it like this and went underneath. Then that would be a minimum. Does that make sense? So between 2 zeros, there has to be at least a max or a minimum. Okay? So here is a question that is a little confusing. Let f be a polynomial function with values of f of -2 equals 0, f of 0 is equal to 5, f of 4 is 0, and f of 7 is -1. Are there any guaranteed extrema? If so, state where they occur. So we just learned that between any 2 zeros, there's at least one extremum, right? So the question becomes, do I have 2 zeros here? So notice that there are a few points that have a 0 in the problem. How do you know if it's an x-intercept? So remember, an x-intercept is when the input, you plug in the input and you get 0. So do you guys agree that this is your x's? Right? And then the answers are your y's. So right here, this is saying, bless you. If I plug in -2, I get 0. If I plug in 4, I get 0. So these right here are my x-intercepts. Okay, so I know you guys don't have a graph, but we can kind of draw a rough sketch of what's happening. Actually, I'm going to make it go farther. So -2 comma 0 maybe looks something like that. 4 comma 0 maybe looks something like that. Zero comma 5 is up there. You guys follow me? Does this make sense? 7 comma 1, sorry, -1 is down here. So we're assuming that it's a function because it says so. So do you guys agree I have to connect the points somehow? So we have 2 zeros. So do you guys agree maybe the function maybe looks something like that maybe? Does that make sense? So according to this, do I have at least one extremum? Do I have at least a max or a min between those 2 zeros? I do. Does this mean that this has to be the function? They only told us 2 zeros, right? Do you guys agree also I could have drawn something like this? Right? That still makes sense. I still have 2 zeros there. But the definition that we just learned says there's at least one. And that's all we can really prove. We don't know enough information to prove anything else. Okay? So the way you would answer this question is, yes, there is at least one extremum in the interval. The zeros occur at -2 and at 4. We don't know necessarily where that... I drew it right here, but you guys agree I also could have just kept going up and then came back down. So we don't know exactly where that extreme is going to occur. So I know it's between, though, when x is between -2 and 4. Okay, almost done. Questions? No questions? Okay. Here's a cool one. We're going to talk about odd and even next week, but here's a little taste of that before we get to next week. If a polynomial has an even degree, then there's either an absolute maximum or absolute minimum. So, I'm going to be really silly right now, but I hope you guys remember it. My kids that had me for Math 3 last year remember me doing this, hopefully. Do you guys remember when we talked about as x goes to infinity, f of x goes to infinity? As f of x goes to negative infinity, you guys remember writing stuff like that? So do you guys remember what's cool about even functions? Even functions, do they look like this, this, or like this? Like touchdown, right? Or, I don't know what this is. But their arms, the arrows are facing the same way, right? So up, or down. We're not dancing. Which functions dance? Odd. So this looks kind of odd, right? Get it? So yes, odd functions dance. These functions either go up, or down. So a positive leading coefficient, do you guys agree like a quadratic is x squared? That's even, right? So the arrows are facing the same way. So if it's a positive leading coefficient, our arrows are facing up, which means this red point is what? A minimum or a max? Minimum. And then on the flip side, if it's a negative leading coefficient, we have an absolute maximum. Okay, this next part is where I want you guys to have your calculators ready, because I'm going to show you guys how to find this on your calculator also. Oh, what am I doing? No. I accidentally opened my YouTube channel instead of the calculator. Okay, just so it's ready to go. If you guys see the first problem in your notes, right, for part A, the 3x to the fourth, can you guys do me a favor and just, first of all, I want you guys to do zoom and then hit 6, because it will basically make your window reset. So zoom 6, and then I want you guys to go back to y equals and type that in. 3x to the fourth minus 2x cubed minus 5. And then hit graph. okay? So there's a part in your homework that actually makes you guys find it. So I want to teach you guys how to find it on your calculator. But let's go back to our notes and just answer the question first. It says, is there an absolute maximum or minimum for each function? So we just learned that if the degree is what, it does. Even, right? Is the degree of this function even? Yes. The degree is 4, which is even. Is the leading coefficient, guys, is it positive or negative? Positive. So do you guys agree? And you guys can see from our graph, it looks, it looks something like that, right? So does it have a minimum or a maximum then? Huh? Does it have a lowest point or a highest point? Minimum, thank you. Because it looks like the lowest point to me is somewhere right there. So this has an absolute. Now, how do you find it? Okay, I'm recording this as a friendly reminder. So what you're going to do is everyone good if I swipe away? Okay. If you guys look, it's really hard to tell what's the lowest point right here, because there's actually like 2 little points right there that are really close together. So what you can do is you guys can change your scale. So what I want you guys to do is I want you guys to hit window. And I'm going to teach you guys what I want you guys to do. I know that it's between, it looks like 0 and 1. So what I'm going to do is, do you guys see how the y value, 1, 2, 3, 4, 5, maybe like -6? I'm going to change the window for the x minimum, change that to a 0. And then for the x maximum, let's just type in like 1.2. For the y minimum, so just scroll down there, change it to -6. And then make the y max like 0.5. Okay. Double check your settings. So do you guys understand what this is doing? It's making it so the x, it only shows the x's on the graph between 0 and 1.2. And it's making it show the y's on the graph are only between -6 and 0.5. So it's basically, it's zooming in on what we want to see, okay? So I'm gonna hit graph, and that did not help at all. Cool. Maybe this is a bad example. But it looks like to me it's like right there. So what I'm gonna do is you're gonna do second, trace, and then I want you guys to go to minimum, minimum, and hit enter. Now it looks like to me it's about right there. So do you guys see how it says left bound? What you wanna do is you wanna kind of pick a point to the left of that and pick a point to the right of that. So left bound, you're just gonna use the arrows and scroll to the left and hit enter. And then you're gonna scroll to the right past it and hit enter again, and then hit enter. And let me check if that's right. Whew, it is. Nice. Got it. Got it? Or no? So hit enter. Scroll like to the right past where it looks like it's lowest, and hit enter again. Hit enter again. There you go. You did it? Yes. Huh? Did you scroll? Let me see. Why does yours have those lines?
I don't know.
Let me see. What is it? 3x to the fourth minus 2x cubed minus 5 or plus 5? Minus 5. So second calc minimum. So I'm going to choose like that and that. No, sign change. What do you mean? It's dumb.
My calculator doesn't like this. Thank you.
You get it? Alejandro, did you get it? Did you get it? Did you guys get it? Everybody here got it? Okay. Same numbers as me? Did everybody get the same numbers as me? No? Can you help her? Huh? Can you help her? Okay. Now, on a test or something, it would be a lot easier to see. Do you guys see how like this curve, it's really hard to tell what is like the actual lowest point? But what else can you guys use on your test, AP test? Desmos. So check this out. This is something that's kind of hard to do sometimes, especially like this function, but check this out. 3x to the fourth. That's not what I wanted to do. To the fourth. What is it? Minus 2x cubed?
Yeah.
Minus 5?
Yeah.
Does it look like that's the lowest point? So if I just click on the graph. There it is. How long did that take me? Like 5 seconds? Okay. Now, on the AP test, whatever you guys are more comfortable with, a lot of things in here we're going to practice using this guy. And the reason why is because, is your Chromebook screen really big? No. So when you guys go to take the AP test, you guys don't have a lot of real estate of space. So if you guys have your AP exam open and then also this open, it's going to be really stressful to go back and forth between the two screens. You guys see what I'm saying? So yes, this helps you guys find it, but I'm hoping you guys feel like in the next problem I'm going to show you guys, this actually isn't that hard. This one, it's tough to tell, but in general, this is not that hard to do. So it just takes practice, okay? So let's practice doing it for this one, part B. So first thing we have to establish is, does it have a maximum or a minimum? And how do I know? What's the degree? 6. But all we care about is that it's what? Even. Leading coefficient, is it positive or negative? Negative. So will this have a max or a min then? Max, good. So therefore, f of x has an absolute max. Okay, is everyone cool with that? Does that make sense? Because if it's negative, that means both arrows are facing which direction? Down. So that means it's going to be highest point because everything's going down towards negative infinity. Okay, so let's go ahead and type this now. So go back to y1. Actually, before you guys do that, do zoom 6 on your calculator again because then it'll reset the window. And then go back to y1, hit clear, and then type this in. This one's a lot more clear, right? Okay, so does everybody have that function on their screen? Now let's say that we can't tell. Do you guys remember in the last problem how we could fix our window? Right now, this is between -10 and 10. Do I really need a window that big to see it here though? So where does it look like it occurs? Between which two numbers? This is -1, this is -2, right? So do you guys agree maybe I could change my window to like -2 to 2? You guys see that? So if I go to window for x minimum, change the x minimum to -2, and then change the x max to +2. You guys can leave the y's alone. And then hit graph again. Did you get it? Did you get it? Okay. Now, do we see that the highest point is about right there? Right? So what I'm going to do is, this is a maximum, right? Because it's going down, down. So I'm going to do second trace maximum. So you guys can just hit 4. And then for left bound, all you have to do is, I know it looks like it's about right there. So what I'm going to do is I'm just going to scroll somewhere to the left of that and hit enter, and then scroll past it and hit enter again. So that way I know for sure that the maximum is between those two bars. Does that make sense? And then hit enter again. And then you guys should get this really ugly answer. Did we get that answer? Yeah? Okay. So, just a reminder on the AP test or in my class, how many decimal places would you round this to? What? 3. So it'd be like -0.853 and then 6.195. Okay? All right, cool. So I'm recording this. There is for sure one question on your homework that asks you guys to do this for 1.4. If you guys need help, please don't be scared to come ask me for help. I want to make sure you guys all know how to do this, okay? So please don't be shy if you guys need help on this. The last one, this is odd, right? So the degree is odd. So just to remind you guys, is this positive or negative? Leading coefficient's positive, right? So the graph does something like this. So this is going up forever, right? And down forever. So does it have a max or min? Absolute max or min? No. So therefore, no absolute max or min. Okay. Now they throw this in there too. This is just a refresher from 1.1. A point of inflection occurs at input values where the rates of change changes from increasing to decreasing or vice versa. This occurs when the graph is changing from concave up to concave down. This all means the same thing. When the rate of change changes, that is when the concavity changes. So that's what we call a point of inflection. So, concave up. What was the visual I told you guys to remember for concave up? Do you guys remember? Teacup, right? Or a smile? Is this graph smiling anywhere? So this is nice because it actually gave you a hint. It gave us the points of inflection. So you guys see anywhere where it kind of looks like a bowl or a teacup? Do you guys agree between these 2 points, it looks like a teacup? And then this right here and this right here is concave down. It looks like it's frowning. So this red part is concave down. This green part is concave up. And then the points at where it changes are called what? Points of inflection. With me, sometimes you guys will see me abbreviate that as POI, points of inflection. That's just me being lazy.